Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. All right, let's have a look at some exam questions on log. So the first one I have here is question 7 from the 2017 paper. So question 7 is one of the long questions. Okay, so there was a fair old amount of marks for this question. Sometimes it is possible to predict the future population in a city using a function. The population in Sapphire City over time can be predicted using the following function. P of t equals s e to the power of 0.1 t by 10 to the 6. The population in Avalon over time can be predicted using the following function. Q of t is equal to 3.9 e to the kt by 10 to the 6. In the functions above, t represents time in years. T is equal to 0 at the beginning of 2010. So for this question, the beginning of time is 2010, and both s and k are constants. The population in Sapphire City at the beginning of 2010, so that was the beginning of time, is 1,100,000 people. Find the value of s. Okay. Let's have a look at this one. So Sapphire City, so I'm up there, I've underlined Sapphire in red. So for Sapphire City, P of t is equal to S e to the 0.1 t by 10 to the 6. Okay, so just a little bit on notation here. This is the population at time t. Okay, so the population when t is equal to 0 is equal to S e to the 0.1. I'm subbing in 0 for t. The reason I'm subbing in 0 for t is time is 0 at the beginning of 2010. Okay, so it's told me that t was 0 at the beginning of 2010 by 10 to the 6. Okay, 0.1 by 0 will be 0. Okay, so it'll be s e to the power of 0 by 10 to the power of 6. Okay, anything to the power of 0, so watch out for that one. Where are my powers and logs and so on and so forth? Anything to the power of 0 is 1. Okay, so that's not 0, it's 1, which means I get s by 10 to the 6 here. What was the population? I never filled that in. 1,100,000. Okay, so I divide across by 10 to the 6. And I get, so 1,100,000 over 10 to the power of 6. Hit the decimal for that, so I get s is equal to 1.1. Okay, so this is just notation. The t in it doesn't mean anything. It is just, suppose, it's just English for population at time 0. Okay, so you just put the population in there and then solve for s. Okay, so this part here where you sub in 0 and you find a constant, it's not an unusual question for logs. It comes up a little bit, okay? And that constant now, so no matter what you get asked from here on in, always fill in 1.1 for your s. Let's have a look at part B. Find the predicted population in Sapphire City at the beginning of 2015. Okay, so still in Sapphire City, so still P of t is equal to s times e to the 0.1 t, wasn't it, by 10 to the 6. Let me just check, e to the 0.1 t. So now we know that the population is equal to 1.1. That's what we found for s, e to the 0.1. Right, what's my t in 2015? So it's the beginning, so 11, 12, 13, 14, 15, so 5 years by 10 to the 6. Okay, And you can see that's just a number. So put it into your calculator. So 1.1, shift the ln button so you get at E, and then into the power I have 0.1 bracket 5. Okay, and then I'm hitting the over arrow so that I jump down again by 10 to the power of 6. Okay, and I'm getting 1813593. Okay, so pop on your mic there now if you didn't get that, because it's just something that you're putting wrong into the calculator. 3593, 1813593.398 is what I got. I suppose they're people, so let's round it, 1813593. Okay, so that was the predicted population in Sapphire City at the beginning of 2015. One thing I am going to do is just compare that number with the 2010 number. What did it tell us? 2010 was 1100. And this is 181. Okay, so it has grown, and I would expect it to grow because the power here is a positive number. Okay, so I would expect it to grow over the 5 years. Part C then, find the predicted range in the population in Sapphire City during 2015. So that was the start of 2015. I'm going to need the end of 2015. So I'll need to find what's P6, or what is the population after 6 years. If 2015, I suppose I can technically put a little 5 in here. It's the population after 5 years. That gave me 2015. If I do P6, I'm going to get either the start of 2016 or the end of 2015, because that's essentially the same night. Okay, so P6 is 1.1 e to the 0.1 times 6 by 10 to the 6. Put that into your calculator. So I have the old one still here in my calculator. So I'm just hitting back, changing the 5 to a 6. So I've got 2,004,330.68. So if I do P6 minus P5, then I'll get the predicted change. So 2,004,330.68 minus 1813593.398. 1813593.398. Okay, and I've got 190,737.2824. And I suppose it's people, let's round it again, 190,737. So you can see in many cases here, guys, just a general thing with maths, it's not telling me to round it to a place of decimal. So I give them both. I give them the non-rounded, and then I round it because it makes sense to round it. Okay, but look what I did when I came down to this one. I used the non-rounded version. Okay, for accuracy. And accuracy is important, especially in higher level leaving cert or physics or any of those subjects. They like their accuracy, okay? So try not round too soon. So I use the non-rounded numbers, and then I round it again at the very end, okay? And I'm doing that to, I suppose, avoid rounding rounded numbers, because when you round numbers that are already rounded, you're moving further and further away from the original number. So in summary, during 2015, the population grew by 190,737. Let's move on. The predicted population in Avalon, so we've changed city now, at the beginning of 2011, so I have a year, is 3,709,795 people. Write down and solve an equation in K to show that K is minus 0.05, correct to 2 decimal places. Okay, don't know what K is right now, but let me go back for Avalon. So Q of T equals 3.9 e to the kt. Well, there's my K. 3.9 e to the kt. I presume it's by 10 to the 6, is it? By 10 to the 6. Okay, so now there's my K. I had no idea what they were talking about up here, but I knew it was Avalon, and this is the function that describes Avalon. So it definitely had something to, it had to have something to do with that. Okay, so we are looking at a year. Okay, so I'm just going to put a note here, 2011 t is equal to 1. Okay, so if you're not sure how to do a sum, okay, for example, always put down this type of information, the stuff that you can, I suppose, take out of the question to get as many marks as you can. Okay, so we know t is 1. Okay, and this is our population, which is 3709. So 3709795 equals 3.9 e to the k times 1 by 10 to the 6. Okay, and even though I know the 1 doesn't do anything, I write it there in the question just in the first line to again get the partial marks for this question. Okay, so we did a few of these now in the last class, okay, where we had to solve for a power. So if you remember what we did, we tried as much as possible to strip away from around the letter that we needed, okay? So I'd like to get rid of the 3.9. I'd like to get rid of the by 10 to the 6. Okay, so it doesn't matter if you do both together or each separate, doesn't really matter, okay? So let's divide by 10 to the 6 here first. So I have 3709795 over 10 to the power of 6. Okay, and it moves the decimal point back 3.709795. Okay, so what that 6 is doing, there's always a decimal point after a number, but 1, 2, 3, 4, 5, 6. So 3.7. Okay, so you can do it on your calculator, or you can do it there if you know your scientific notation. So I've got 3.709795 is equal to 3.9 e to the k, divide across by 3.9. So all the time I'm stripping away from around what I need. Okay, so divide that by 3.9. And I'm getting, I'm just going to come up here, guys. I am getting 0.95122948872 is equal to e to the power of k. Okay, now, again, you can do the switch. Okay, no problem at all. Or you can use these rules, no problem at all. Okay, so I'm going to do the opposite of e, which is log to the base e, or ln, whichever you prefer. Okay, so I'm going to write it in red so you can see what I'm doing. So log to the base e of e to the power of k. Okay, why do I do that? Because I know e and log e cancels. Okay, they're the opposite of each other, and I'll be left with just k. What I do to one side, I have to do to the other. Okay, so log to the base e on this side of 0.95122948872 equals. Okay, and my e and my log e cancels, and I'm left with just k. Okay, so in my calculator, always remember that log to the base e is ln. Okay, it's the exact same thing. So instead of putting log to the base e, I'm just going to hit ln answer, because I know my answer has all these decimal points in it. And I've got minus 0.049999, 2 decimal places. I just fix my minus 0.049999, 2 decimal places minus 0.05 is equal to k. Okay, so that's us writing down an equation, which was this one, and then solving it to show that k is minus 0.05. Okay, so very much what we were doing in the last class, where we had to use logs to solve for powers. You will always have to use logs or the switch to solve if what you need is the power. Okay, that is what logs is for. Okay, part E, find the year during which the populations in both cities were equal. So basically they're asking, when is Sapphire equal to Avalon? Okay, when is the population in both equal? Okay, and this one was Q of T. And this one was P of T. Okay, so when is P of T equal to Q of T? Okay, let me just tidy that up. Okay. So I have 1.1 e to the 0.1 t. When is that equal to 3.9 e? Don't forget to fill in your k to the power of minus 0.05 t. And I forgot all the 10 to the 6s. Okay, so this is it in English. When is the population of the two cities equal? All I've done then is write down the functions of the two cities, and I've let them equal to each other, okay? And what we're going to do is try and solve that for t, okay? So a little bit of formula manipulation here, because you can see t appears twice, okay? So we'll have to handle that. We're going to need logs because what we need is in the power. Okay, so let me work through this. The first thing I see is by 10 to the 6 on both sides, okay? So if I divide across by 10 to the 6, what I do to one side, I do to the other. You can see they're cancelled. So I'm left with 1.1 e to the 0.1 t being equal to 3.9 e to the minus 0.05 t. Okay, so when you're doing formula manipulation or when you have to solve something and it appears twice, what you have to do is bring what you need to one side. So I'm going to bring all the t's over to the left and leave the numbers on the right. Okay, so nothing different to what I would do with any algebra question. I'd bring the variable to the left, the numbers to the right. Okay, so how does it work here? Well, I'm going to leave the e to the 0.1 t. I have to leave the e's where they are because the t is attached to them. So leave that on the left, okay? How is this attached to 3.9? Well, they're multiplied, so I have to divide by that to cancel it. And what I do to one side, I have to do to the other. So I'm ending up with this being on the bottom. Okay, so what's that equal to? Well, 3.9 is already on the right, so leave it there. And if I divide both sides by 1.1, this is what I end up with. Okay. So I suppose summarize, what was I doing? I need to solve for t because I need to find what year. So t appeared twice. So how you handle it is you bring all the t's to one side, and you're going to effectively, like if it was a normal algebra, you'd factor it out. In this way, we'll find a way to resolve it so that we only have one t. Okay, we'll use the rules of indices. And then you brought the numbers to the other side. Okay. Let's continue up here. Okay, so using the rules of indices, when I have the base number the same, the base number to a power over the base number to the power, can you remember I subtract the powers? So we have e to the power of 0.1 t, so my base number is e over e to the minus 0.05 t. Okay, so my a in this case is e, this is my p, this is my q, and I subtract the powers. Okay, so that's what we're going to do. So we end up with e to the power of 0.1 t minus 0.05 t. Okay, and that's equal to, in my calculator, I'm going 3.9 divided by 1.1, and I'm getting a big decimal, so let's leave it as a fraction. Okay, so 0.1 t minus 0.05 t minus. So 0.1 plus 0.05 is 0.15. Okay, so I'm getting e to the power of 0.15t is equal to 3.9 over 1.1. Okay. When what you need is in the power, you need logs. Okay, so either do the switch or use these rules, whichever is your preference. I'm going to do log to the base e. Okay, so again, I'll write it in red so you can see what I'm doing. Log to the base e of 0.15t is equal to what I do to one side, I have to do to the other. 3.9 over 1.1. Okay, and remember, log to the base e is the same thing as ln. Okay, so why do I write it as log to the base e here instead of ln? Well, I just do it so you can see the rule. Okay, maybe if I was just doing it myself for myself, I would put down ln, but just I think sometimes it's useful to see the e and the log e cancelling. Okay, rather than ln and e cancelling. But it doesn't matter which one you put down whichever one makes you comfortable. So I get what's left in the power. Okay, so log e and e cancels, so you're left with 0.15t, and of course I have to suffer the consequences of log e on this side. Okay, because what I did to one side I have to do to the other. So I'm going to put into the calculator ln of 3.9 over 1.1. Let's see what we come out with. Again, it's quite a long decimal, but I'll just leave it there in my calculator. 1.265666373. Okay, and then divide across by 0.15 to solve for t. So t equals, so I'm leaving that answer in my calculator and I'm just putting in divided by 0.15. And I got 8.437, okay, years. So, and going back to the question, I always go back to the question to see, is there a certain number of decimal points they want? Am I actually finished the question? Did I answer what they asked? Well, I didn't yet because it says find the year. So what year are we in after 8.5 years? You see, and this is where I could very easily make a mistake. So we started in 2010. So we start at the beginning of 2010. So we're going to be still in 2018 after 8.5 years. Yeah. Okay. So your answer then, 2018. Okay. So in 2018, the population of Sapphire City will be equal to the population of Avalon. Okay. So a fair old bit of work in part E. Okay. So some marks just to give you a feel for questions. Part A was worth 10 marks. Part B, where you just had to put the numbers into the calculator as long as you knew what you were doing, was another 10 marks. C was 5 marks. D was 15 marks. So you can see how important it is to be able to solve for a power. And E then was just 5 marks. Okay, F and G then are worth 5 marks each. I'm going to leave them for now because I know you don't have calculus done. Okay, this word average will be integration. So it'll be 1 over b minus a, the integral of Avalon. Okay, and then the function q of t down here to find the predicted, so rate of change is differentiation. Okay, that's another word. So differentiate it and then sub in t equal to 8. Okay, and that will give you the rate of change at the beginning of 2018.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.